welcome back. So in this video we're going to continue our discussion on pointers, and in this video we will generally look at pointers and the constants and the relation between pointers and arrays, and finally we will end up with a concept called pointer arithmetic. So pointers and constants, as you know, if we declare a variable as constant, then the value of that variable cannot be changed. If you try to change that value, you would get a compiler error, right? In the same manner, you can also declare uh, use constant keyword for the pointer too, but um, it can be done in two ways, and when you do it in two ways, it will have two different results. First thing is to place the constant keyword before the data type, like here const int pointer x equals ampersand y. In this case, x can store any other address. Like you can do that, there is some variable called z, and you can do that x equals ampersand z. You can do that after initialization, but the the value in that memory location nothing, but here there is a value for y, right? You cannot change the value of y through x. Don't get confused here. The value the x is pointing to nothing, but the value in that memory location cannot be changed, but x, the value of x, nothing but the address that x stores, can be changed. The second way is to place the const keyword after the data type. In this case, the address that the pointer stores cannot be changed, but you can change the value it is pointing to. So for example, here the value x is pointing to nothing, but the value of y can be changed through pointer, but x cannot point to any other address. And you can also do the following syntax in this if you perform this expression, the value of the address that x stores and the address and the value that x is pointing to both cannot be changed. So if you want to make the pointer completely constant, then you should perform this expression. So let's go into Visual Studio Code and try out these examples. So let me declare three variables. Let's declare three variables: a equals 15, int b equals 20, and int c equals 25. So now let's do something like this, like const x equals ampersand a. So in this case, you can change the value the pointer is pointing to. Like you can do something like this, like a equals 50, and this is completely valid. Sorry, x, right? Huh. Percent d and x, and this is completely valid, and you can see that even it executes properly. And when you run the executable, 50. But if you try to change the, if you do something like this, ampersand b, this would give you a compiler error. See, you've already got an error here, and let's try to build it. So let's remove this const and place it before int. So now you cannot change the value that x is pointing to, but you can change the value that x stores, nothing but the address. So you can do something like this, equals ampersand b, and it is completely valid because this is completely valid, and you can see it prints out. Oh, 20. But you cannot do something like this. So after doing all these things, you cannot do something like this, equals 6. This gives you an error. So this is all about constants and arrays. So let's look at the next concept, pointers and arrays. Arrays can also be assigned to pointers, and you just have to specify the name of the array without the ampersand symbol. So it is as simple as this: int pointer equals array. You don't need to specify the index number, you don't need to specify the ampersand. In this case, the whole array will not be assigned to the pointer. The first element in the array will be assigned. And even the following expression does the same as this expression. For you can also do this like int pointer equals ampersand array sub 0. Remember, arrays are 0 based, hence the first element would be represented by 0. Hence, let's go into before looking at pointer arithmetic, let's once go into code blocks and let me show you an example of how. So int array 5 equals 1 comma 2 comma 3 comma 4 comma 5. So at this point, let's try something like this: ptr equals array. So let me write a for loop. Int, no, yeah, let me write a for loop. No. So let me do something like this. Let's print out the value. Let's write a for loop for int I equals 0 and I should be less than 5. So here you can do something like this: plus plus I and plus plus ptr, and every time, sorry, so you can just write a print statement something like this: %t and ptr. So this gives the same output as the before one. So this pointer arithmetic is much useful with character arrays. Remember what character arrays are? Nothing but strings, right? So let's do something like this. Let's create a character array, nothing but a string. Call let it be hello world. So you generally, to calculate the size of a character array, for example, you generally use strlen function, right? So instead of using strlen, with the help of this pointer arithmetic, I mean, I don't mean that you shouldn't use strlen from now on, but I'm just saying that you can do this using pointers. So let's assign a character pointer which equals string. So let's do something like this. While remember, character, even though there are, you may see that there are 10 10 characters and 11 characters including the space, but there is an extra character for null character, right? So the null character will always be at the end of the string. Hence, you can use that condition like ptr should not be equal to null character. I mean null terminator, nothing but. So printf, so let me create a variable for len, called len, and now plus len and plus pointer. So printf stolen array size using, so let's use stolen first. So let's use stolen first. Okay, percent d and stolen of string. So copy using ptr arithmetic, nothing but pointer arithmetic. So len, you would observe that both will 11 and 11. The even the Stirling function uses a similar kind of syntax. Hence, you will see that the array size is same. So in this way, they are really useful using pointers. Hence, pointer arithmetic is one of the main reason why you, you use you use them, because they come in handy when you're dealing with strings, right? And finally, that's it for today's class. And I want to give you a quick challenge for today's class. Pointer arithmetic. So let me run bash here. So you would see what would the challenge be. You have to create a program which asks you to enter a string, which asks you to enter the string. For example, Let me type hello world something fishy thing, and you see there are 28 characters. And let me type hello world, and it says that the enter characters is 5 because we are using scanf, hence it only the scanf takes the parameters until the uh, white space character is reached, a space character, nothing but. So if you type something like hello o, it would give you 5, and if you type something like h o o o o o, and it would give you 1, right? So you have to create a program which is very simple. You just have to ask the user to enter a string and should produce the number of characters, nothing but the length of that string. Remember, you can only take the number of characters entered until the white space character. So you can even add a note for the user. And that's it for today's, guys. It was a wonderful session with you, and thank you. And I'll be back with another video on pointers, which has the most important concept, that is nothing but dynamic memory allocation. That will be the last concept of the pointer section. And with that, we are near to the end of our C programming course. We are left with only a few topics. Once you complete pointers, the remaining concepts will be damn easy. So thank you.